So let's take a look at using your calculator and doing an application of logarithmic models. First thing is let's take a look at using your calculator to figure out the logarithm and natural logarithm of values. For this first one, I found that the log of 27 was 1.43. So what I'm going to do is I am going to say era 27, and I'm going to hit this log base 10. That's going to give me the 1.43 for the log of 27. There's your answer for that first one on the log. I hit 27. Next one, let's find the log of 1,723. So 1,723, log key, up with 3, 4. Again, log key, cell phone. The natural log, 7.6 for this one. 7.6, enter in. I'm going to hit the LN key, which is right there. That and get 2.03. Last one, the natural log of 172, 5.5. Now, if you have a Texas Instruments graphing calculator, I can go through that as well, just in case that applies to you. Doing these real quickly, I think the keystroke is different than the cell phone. So log of 27, log of 27, 1.43. The log of 1723 is 3.4. The natural log, LN key, and where I'm getting those from on calculator, there's my log, there's my natural log. LN of 7.6, there, natural log 70. Depending on what type of calculator or cell phone you have, Let's take a look at an actual application of doing this logarithmic model, and we're going to apply it to finding the percent, the final percent of an adult and their height. Here we have a model that's based upon the finding the percent of a final adult height for males between 13 and 18 years of age. What we're going to try to do is we're going to try to find percent of final adult height for a 14-year-old male. So what I'm going to do is in my model, wherever I have an X, I'm going to plug in 14, and 14 is definitely between 13 and 18. So I have 16 log 14 minus 12 plus 84. So all I did was substitute 14 model. Now, I have 16 log 2 plus 84. The log of 2, I enter that in my calculator, is 0.30 at 84. 16 times 0.3, 4.8 add 84. I add those two together. 14-year-old male, 88% height. We're going to do the exact same thing, except we are going to apply this model for a 17-year-old male. Percent adult height, this model, instead of 14, I'm going to plug in 17. 16 log 17 minus 12 is 5. I'm going to add 84. My calculator tells me that the log of 5, 0.70, add 84. 17 times 0.7 is 11.2. Add 84. 17-year-old is a little bit older, a little closer to their final adult height than a 14-year-old. They're 95.2% their way to their adult height. To apply this even more specifically, let's say that 17-year-old was 6 feet tall. We want to figure out what their final adult height is going to be. So their final height as an adult, using this model as a predictor, they are 6 feet tall at 17. I'm going to divide that by 0.952. That comes from 95.2%. I move that over to a decimal for a 17-year-old. I divide those two together. I would get this adult as that 17-year-old as an adult is 6.3 feet tall as adult using that model.